Okay, I almost got it all in on the last video, but then I forgot to tell you about how to do your practice questions tonight, so I had to make a new one. So I figured I may as well finish up Newton's third law. So what I was saying just as the video ended was, really, it's the reason it's hard to get out of bed in the morning, right? Your mother or father, whoever's saying, why are you still in bed? And it's like, well, because the bed's not pushing back hard enough. It's the bed's fault, not mine. And that's connected to trying to get out of a chair. Have you ever sat in one of those comfy chairs that you just sink into and they're wonderful, but then it's impossible to get out because you're pushing on the chair, but it doesn't have any structure, any form to push back. And if you've ever watched an older person try to get up, either out of a soft chair, and it's why older people tend to like harder chairs, it's easier for them to get up. But as they get older, I'm thinking of my mom who's like 90, right? She doesn't have as much arm strength anymore. So to get up, she has a hard time pushing with enough force so that the chair can push back to get her out. So usually what I do is I put my arm in front of her and then she holds my arm and she pulls on my arm and then my arm pulls her up. Right? You should never grab an older person's arm and pull because you could pull it out of the socket. So it's always better to let them pull. But as they lose muscle, that's harder and harder for them. Okay, just a couple of other examples since I'm here. One is a canoe. If you've ever been in a canoe or a raft and you decide you're going to, maybe you're on Killarney Lake and you decide you're going to like jump out of the canoe and do this perfect dive into the water to impress everyone. Well, unless there are other people in that canoe, you're going to push on the canoe. Yeah, I know canoe isn't shaped like that, right? So here you are, and you're going to push backward on the canoe so the canoe can push you forward out into the water. But if you push with too much force because you want to do this big, huge, elaborate dive, instead all that's going to happen is the canoe's going to move backward and you're going to do a belly flop. Right? Because if you push with too much force, the canoe can't push back. And then the last one is, have you ever pushed a car out of a snowbank? Right? So your car's stuck in the snowbank. What you shouldn't do is you shouldn't be sitting in the car and pushing on the dash. That is not going to be helpful. Instead, you stand out here at the back of the car and you put your two hands on the car, and then where should you push? You should push down and back on the ground with your legs, because your legs are or at least mine are a heck of a lot stronger than my arms. So you push down and back on the ground, and the ground pushes with an equal force back on you, and that's what pushes the car out. If you just push with your arms on the car, you're probably not going to get it out. But if you use your legs pushing on the ground, then you can get the car out. And all of this is Newton's third law. Now, isn't it cool? You got to admit that it is. All right. So this evening, there's a little sheet that looks like this. It has a whole bunch of little boxes that you will find attached to your work that's being given for today. And the front side are where the forces are going east-west. Okay, so to the right is east and to the west is left. Left is west. And all it wants you to do is find what's missing. Now, you're going to use Newton's second law equation, F net equals ma. Okay, and if you look, I'm looking for one where here it tells you that the acceleration is 3 meters per second west, right? And so if it's 3 meters per second west, then the F net will be west as well, okay? So these are vectors, and you have to take into consideration their direction. The other equation you'll use, remember F net is just the sum of all the forces. So it'll be F1 plus F2, taking into account their direction. So if we look at the very first one, there we go, it wouldn't blow up for me before. F1 is 20, this one's F1, it's 20 newtons east, and F2 is 4 newtons west. So what's F net going to be? It's just going to be 16 newtons Always keep the direction of the larger east. Okay, so make sure that all your F's, all your A's have units and directions. So now you have F net and M, so you can find A. It's just going to be F net divided by M, so 16 divided by 8, so it should be 2 meters per second squared, and A is always in the same direction as F net, so it'll be east. Okay? And so you don't have to show any of your work unless you want to, but like if you maybe can do this in your head. If you see the words uniform motion means that the motion isn't changing, and if the motion isn't changing, it's telling you then that A is 0. And if A is 0, then F net must be 0. And if F net is 0 and F2 is 10 newtons to the west, what must F1 be? Okay? The only other equation you might need when you get a bit further down is A equals VF minus VI over delta T, because they give you VFs and VIs down here. Okay, so back to grade 10, A is equal to VF minus VI over delta T. Now, if we were in class, I would ask you to do the front side today, and then tomorrow I'd ask we could address any questions, and then tomorrow I would explain the back side and I'd get you to work on it, and we'd address any questions, and then I'd give you another day or two and I'd ask you to hand it in. So perhaps by the end of the week you could do pictures of this and post them for us so that we could take a look to see how you're doing. And tomorrow I will go over a few that I know will give you issues. Okay, so give it a try, and it's just getting you used to F net and A and how to do it. All right, very good.